I bet it's really frustrating when you have to prove a trig identity problem like this on your homework. And if you're worried about your AP exam, stick around because I promise you're going to understand this in just a few minutes. Now, we have an identity for cosine of 2 theta, but what about this cosine of 4 theta on the left? I personally want to start this problem by working on the left side of the equation, but there's no hard rule on that. You can solve it differently and tell me how you did it below in the comments. But the problem here is, what is the identity for cosine of 4 theta? If you only know the identity for cosine of 2 theta and you don't want to be stuck on your exam, you need to be able to make progress and show what this is. So let's make the problem look like something we have an identity for by allowing this 4 theta all to be equal to u, where u is a new variable. And so remember, if we're going to rewrite this in terms of u, anywhere we see a theta now, we have to substitute it for an expression in terms of u. So you need to solve this for theta as well, which will give you 1/2 u, which means now that on the right-hand side of the equation, anywhere you had a theta before is now going to have this 1/2 u. Now on the left-hand side, cosine of 2u is now a very obvious identity we can use, right? That is just going to become cosine squared of u minus sine squared of u on the left. And I personally don't like working with the 1/2 angles on the right. So my choice now is to just basically go back to using theta everywhere, which is going to not only knock out these 1/2 angles on the right, but it's also going to make it clear now what this identity for cosine of 4 theta is on the left-hand side. So let's go back to using theta and check this out. We know the identity for the cosine of 2 theta is cosine squared of theta minus sine squared theta. And now we just showed a new identity for cosine of 4 theta on the left, where instead of using theta as the argument to the trig functions, it's 2 theta here, so very close. And now we want to keep making progress though, because we have 2 theta arguments on the left-hand side, but we have angles in terms of just theta on the right. So maybe this is confusing, and that's understandable. But what you can actually do here is the following. Check out this sine squared of 2 theta term. Sometimes it's helpful to rewrite sine squared of something as sine of something all squared, because then when you have it as sine of 2 theta all squared, whatever's inside the square is now very clear that we can use the sine of 2 theta identity. Remember, that's 2 sine of theta cosine of theta. So I'm going to put that in here, and we have this new expression. And now when you square it, you're going to get on the left-hand side cosine squared of 2 theta minus 4 sine squared of theta cosine squared of theta. Now, there's a hint here because on the right-hand side, we have 1 minus an expression. Now, we don't have it on the left, but think about the sine squared of theta plus cosine squared of theta equals 1 identity. If you were to subtract one of those trig functions on either side of the equation, you could manipulate that as 1 minus something, right? So on the left-hand side here, with this cosine squared of 2 theta, if I want to rewrite it in terms of something that is 1 minus another trig function, remember for cosine squared of 2 theta, we can prove that out as 1 minus sine squared of 2 theta. And now you have the rest of the expression here. And so now the next step you can do is just like before. Remember that sometimes you can repeat using the same identity we used earlier in the problem. Some problems require you to do that actually. And above, we use the identity for sine of 2 theta, and we can do that here again because sine squared of 2 theta is the same as 2 sine theta cosine theta all squared. And now it's becoming very obvious how to complete this problem, because when you apply the square to the 2 sine theta cosine theta term, you're going to get 1 minus 4 sine squared of theta cosine squared of theta minus that same thing again, equaling what we started